Hello, my dear students and the rest of the learners. Welcome to this presentation in which we are going to learn about the topic Introduction to Computer Networking. My name is Meme JM, or you can simply call me Emily Swap. In this presentation, we are going to discuss computer network, the benefits of computer networking, types of computer networks, network topologies, and lastly, we shall look at transmission media. Let's commence our discussion by definition of various terms that we find in networking. We commence with computer network. A computer network is a collection of computers and other devices that are linked together using data communication links or channels for the purpose of exchanging information and sharing of resources. A network is a collection of independent entities that are arranged in a certain way in order to enable communication between them and facilitate in resource sharing. Examples of networks include road networks, railway network, computer networks, and telephone networks, amongst others. However, in this presentation, our focus will be on computer networks. Networking, on the other hand, is the process of connecting various devices and computers within a certain range of space with the use of transmission media so as to facilitate communication. A standalone computer is one which is not connected to any other computer. A transmission media is any physical or non-physical link between two or more computers and in which a signal can be made to flow from source to destination. Computers which are connected to a network are called stations. A server, on the other hand, is a computer that is dedicated to servicing requests for resources from other computers, which we are calling workstations on a network. Modern networks can either be server-based or peer-to-peer based networks. A client-server network is a network where powerful, dedicated systems that we call servers provide resources, files, devices, and even processing power to individual workstations or clients. It is important to note that a client in a network is a resource. For example, a computer that rely on the information or data or instructions that have been stored in another computer that we call a server. And therefore, a server, on the other hand, is a computer that provides, holds, or stores information, data, instructions, or even programs or files that are needed by other computers. So it provides those other computers that we are calling clients with what they require. And therefore, a client-server network is an interconnection of both clients and the server. You have several clients, but you have For example, a single server, or you can even have several servers. For example, if you have a printer that is going to be used by all the computers within the network, it provides all the other computers with a printing service, then that can be also called a server. And in this case, it will be a printer server. So you can have a printer server, and also you can have a computer, which is a server. A peer-to-peer network is a network where each system has equal capabilities or responsibilities, such as home networks. In this case, you have computers with equal capability, and any of those computers can be able to provide or to service or to serve the other computers with certain resources. What are the benefits and limitations of computer networks? We commence with looking at the benefits of networking. Number one, we have resource sharing. A resource in the network environment means data, information, files, printers, modems, communication links, storage devices, fax machines, application programs, and any other component that can be attached to the network for access by users. With a network, any user within it can access any resource that it requires. This centralized access to data and information leads to less wastage of time, and hence it leads to greater productivity. Through resource sharing, organizations are able to lower production costs through the best use of the available resources, because a single resource can be installed on the server and then shared amongst all computers, and thus avoiding patches for the same resource for each computer. Number two is remote communication. This is the transmission of data signals between two communication devices that are located at different geographical locations. It eliminates the need for people to travel to attend meetings, because this can be done through sending emails, video conferencing, and telecommuting. It is through remote communications that people can be able to share ideas and pass messages over the internet. It gives a lot of freedom to the network users, which translates to more productivity. Number three is distributed processing facilities. Distributed processing is the activity of running the source programs or databases on different computers which are on the same network. It implies that computers can do processing at their own dispersed locations or departments, and can share programs, data, and other resources with each other. It improves the flow of information and saves time as well as resources. The main advantages of distributed processing are: number one, the failure of the central computer does not affect the operations of the other terminals. Number two, the processing load is shared equally, hence there is no time wastage. Number four is cost effectiveness. Reductions of resources in networking lead to reduction in costs. Although the initial purchase and laying down of network components may be expensive, the savings experienced and the value added to service delivery make them a ready choice for enterprising managers. A network greatly increases the efficient use of scarce resources. Also, computer networks have enhanced daily communication by providing a paperless communication environment. Users can send electronic messages and mail to each other instead of having to bear the cost of stamp duty or delivery charges. Also, a company executives may not need to travel across continents in order to hold meetings, for they can hold electronic video conferences, thus saving the fare. Due to the benefit of sharing resources, fewer devices have to be purchased and maintained. The devices both can be of higher specification, and sharing this equipment between many users ensures that it is used more efficiently. Providing shared modems and fax systems allow the system administrators to monitor and control the use of facilities. Number 5 is reliability. The two ways in which a computer network is reliable are, number 1, the data can be transferred with minimum errors from source to destination. Secondly, in case one computer breaks down, a user can still access data and information from the other computers using another computer on the network. In networking, information is not located in one single machine. It reduces the chances of data loss and corruption. If data is lost in a standalone computer system, the chances of retrieval are very high and they are very much limited if there was no backup. I repeat, if data is lost in a standalone computer system, the chances of retrieval are very much limited if there was no backup. But in networking, there is reliability in the sense that the data sources can be available at various points. Hence, reliability is also in the usage of the shared resources and in access. So, what are the main advantages of using networks? Number 1, the sharing of resources, or there is sharing of resources and information. Number 2, there is provision of local facilities without the loss of central control. Number 3, there is even distribution of work, processing laws, amongst others. Number 4, there is improved communication facilities. And number 5, it earns data redundancy. So what are the limitations of networking? Much as there are many benefits of using a network, there are also some drawbacks, limitations, and disadvantages that we find when we network our computers. One of them includes security issues. Data and information that is held on a network is prone to more illegal access threats than if the computer was not in the network. Once a computer is connected to the network, especially the internet, many people can access it not only physically, but also virtually over the network. Number two is high initial costs. The initial cost of buying network hardware and software is normally very high, including training of network administrators, as well as other users, and in maintaining or for maintaining the network. Number three is moral and cultural effects. Large networks like the internet have chat rooms and messaging services that may enable underage children to meet peers and adults on the net, with some of whom may have bad intentions. In addition, connectivity or networking links or enables an individual to be able to access pornographic and other negative material that has also made the fight against social problems such as HIV and AIDS, banned sexual behavior, drugs and substance abuse to become more complicated. Number four is the spread of terrorism and drug trafficking. The internet provides a rich recruitment ground for all types of illegal activities, such as terrorism and drug trafficking. The easy flow of information from one place to another keeps even those who are on the wrong side of the law to communicate easily. Terrorists and drug traffickers use information networks for their business communication. Number five is over-reliance on networks. The disadvantage of all business processes in the society depending on computer networks is that if by any chance the network fails or goes down, then many systems in the society can be brought to a halt. Number six is network failure. There is a danger which may paralyze the operation of an organization between or besides damaging files and the programs. Number 6 or 7 is slow response rate. The file server shares its processing time and memory equally between each user. The more the users accessing a file server at the same time, the slower the server will be in handling each request. To overcome this, it is important to have enough random access memory. Another solution to this problem is to add additional file servers to the network in order to share the workload. Having looked at the benefits and limitations of networking, we can now look at the types of computer networks. The two broad types of network systems are number 1, point-to-point communication, and number 2, we have what we call multi-point or drop communication system. Let's now look at what we call point-to-point communication system. This is where the communication devices are directly linked by a physical media. Its advantages include, number 1, transmission is done with minimum delay. Number 2, signals don't suffer corruption by other transmissions. And number 3, communication is usually private. When you look at point-to-point, or what we are calling multi-point or drop communication system, this is where several devices are directly connected to one another or to more devices. Where several devices are directly connected to one or more devices. It constitutes a multi-point communication system. Although several devices are interconnected, communication takes place at two communications at a time. The two types of network configurations are, number one, we have what we call dedicated server network, and number two is what we call peer-to-peer networks. Undedicated server network, or in undedicated server network, specific computers take on the role of a server with the other computers on the network accessing resources as clients, which includes workstations and servers directly connected to one another. The servers are normally dedicated to handle network requests from their clients. From this diagram, you can see that we have one computer that is serving as the server, that is a computer that is meant to meet the requests, or that is meant to meet the requests from the other three computers, as you can see. And therefore, this is the server, or this computer that we are calling the server may contain, for example, a program that is required to be used by each of the three computers that we are calling, in this case, clients. So a network in which we have clients connected to a server where this computer is purely meant, the computer we are calling server is purely meant to meet the requests from the other computers, then that kind of a network is called dedicated server network. A peer-to-peer network, on the other hand, is a network that is formed by computers that have equal capabilities. It includes all computers sharing and using same resources, with each computer operating both as a client as well as a server. That means that each of the computers, for example, in this diagram, in this network, each of the computers may contain a resource that the other computers would like to have. Or it may contain, for example, each of them may contain a program. If one computer contains a program that is to be used by the other computers, or that must be accessed by other computers, then it simply means that due to the fact that each of these computers may contain a resource that the other computers will require, then at the end of the day, what we have is what we call peer-to-peer network. Each computer is acting as a client. That means it will make a request at one time or another to be supplied with something, or to be allowed access to a certain resource that is in another computer. While at the same time, other computers in the network will also make requests for a resource that this computer also contains. So the peer-to-peer relationship also means that all computers have equal access and responsibility in the network. Generally, we have three main types of networks. These are the local area network, abbreviated as LAN, metropolitan area network, abbreviated as MAN, and wide area network, that is abbreviated as WAN. What is a LAN? This is a connection or a collection of microcomputers and other devices that have been linked together within a relatively small well-defined geographical area that does not exceed 3 kilometers in radius. For example, this can be a network within one building, one floor space, or a block of buildings in an organization. My dear students and the rest of the learners, the most important aspect to remember when we are grouping or classifying networks, either as LAN, MAN, or WAN, is to look at the area of coverage by the network. And therefore, for LANs, a network is formed that ranges from 0 to 3 kilometers in radius. Anything beyond 3 kilometers is not a LAN. It will be another type of network. The 3 main variables that must be considered when a LAN or a LAN is configured are, number 1, the data transmission medium that will be used. Number 2 is the physical arrangement of workstations in relation to one another. And number 3 is the method by which users can access the network. So the main characteristics of local area networks include, number 1, they are called local because they occupy only one small physical location that we have said that it should not exceed 3 kilometers in radius. They can be peer-to-peer networks, or they may be client-server networks. They have high speed data transfer rates. Also, all data is part of the local network. A LAN's ability to share information and communicate with the devices and the computers on the network has many benefits for its users, which include, number 1, hardware, software, and data to be shared. Number 2, the storage facilities can be shared. Number 3, it's cheaper to buy one copy of a software application and pay the license fee for several machines than to buy individual packages for each computer. Number 4, users can work together on a single document. Number 5, users can communicate using email. Its main disadvantages, however, include, number 1, the initial setup cost is normally high. Number 2, there is increased risk of data corruption. Number 3, there is a greater risk from viruses because they can be easily spread. Number 4, if the file server fails, all the workstations are affected and work stored on shared hard disk drives will not be accessible, nor will it be possible to use network printers. Number 5, networks can be complicated to maintain and may require a network manager. The local area networks can also be divided into 2 categories based on how the computers communicate with one another. These are the client-server networks and the peer-to-peer network that I have already defined and explained. The second type of network is called metropolitan area network, which is abbreviated as MAN. A metropolitan area network is a connection of computers and other telecommunication devices in which several LANs are connected together within a certain limited geographical area, like a town or a city, but that does not exceed 50 kilometers in diameter. It's very important, my dear students, and the rest of the learners, to note that a metropolitan area network should not exceed a diameter of 50 kilometers. Metropolitan area networks increase the network capacity of an organization to connect within the area. For example, a municipal council network. Metropolitan area networks connect several lands together using high-speed telephone lines, such as leased lines or wireless communication. Remember that I have already said that a local area network should not exceed a radius of 3 kilometers, but a LAN, we are saying, should not exceed 50 kilometers in diameter. That simply means because 3 kilometers are within the range or are within the 50 kilometer diameter, then MANs are composed of several LANs. You have one LAN whose radius does not exceed 3 kilometers, and you have several others whose radius does not exceed 3 kilometers. But then in combination, when you interconnect them together, they form a metropolitan area network whose diameter should not exceed 50 kilometers. And we are saying that metropolitans connect several lines together using high-speed telephone lines, such as leased lines, or you can make use, or they can make use of wireless communication. The main characteristics of metropolitan area networks are, number one, we have wider geographical coverage than LANs. Number two, there is higher data rate transfer compared to wide area networks. Number three, MANs serve as backbone for LAN interconnection. And number four, they support integrated data or voice service. The metropolitan area network infrastructure may be owned by a company that has offices across a metropolitan area, or by a service provider who provides network services to subscribers in the area. The third type of network is called the wide area network, abbreviated as WAN, which can also be referred to as long-haul networks that we abbreviate as LHN. This is a connection of huge networks of computers and telecommunication devices spanning large geographical areas that are thousands of miles apart. Wide area networks cover unlimited geographical areas across the country and the entire world. The internet is the largest and most common wide area network in existence today. Information can be transmitted using special high-speed telephone lines, microwave links, satellite links, or a combination of all the three. The main characteristics of wide area networks include, number one, we have low data rates and operational speeds compared to local area networks. Number two, there is a high degree of vendor independence, whereby most wide area network equipment can be acquired from a variety of vendors. Number three, most wide area networks are operated by public telephone and telegram (PTT) bodies, except in the United States of America, where private carriers are major service providers. However, these days, we have various bodies that are in charge of offering wide area networks. Number 4 is difficulty in interconnecting the various wide area network types due to incompatibility addressing schemes and protocols. Where interconnections are possible, a lot of functionality is lost. Let's now look at what we call network topologies or network configurations. A topology is the way in which computers and other devices have been arranged, or how data is passed from one computer to another in a network. The choice of topology to adopt depends on various factors, including reliability, expandability, and performance. The network topologies can be viewed in two main ways. These are logical and physical topologies. What is a logical topology? A logical topology is also called signal topology. This deals with the way data passes from one device to the next in the network. Examples of these topologies are Ethernet and token ring topology. What is an Ethernet logical topology? This is a topology whereby all computers listen to the network media and can only send data when none of the others is sending. Token ring logical topology is a topology whereby a special package of data that is called a token goes around the network, and only the computer whose address is on the data held in the token will take up the token to read the data and then release the token. The token can then be captured by another computer which needs to transmit data. The other type of topology is what we call the physical topology. A physical topology deals with the physical layout or arrangement of components on the network. Examples of physical topologies include star topology, bus topology, ring topology, mesh topology, and tree, or what we call hierarchical topology. Let's now focus on what each of these physical topologies entail. The first topology that we are going to look at is called star topology. In this arrangement, all the devices are connected to a central hub through which data from the various nodes pass across the network when the nodes communicate. All the nodes are connected in the form of a star by either point-to-point link or by a point-to-point link to a common node, which is often called the server. Communication between any two nodes has to take place through a central switch or the server. The sending node requests the server for a connection to the destination node. My dear students and the rest of the learners, it is important to note that a node is any device that is connected within a network for the purposes of performing a certain function. That's what a node is. And therefore, you can have a sending node or you can have a receiving node. You can even have a node that performs both the task or the function of sending as well as receiving. When the hub receives data from a transmitting computer, it broadcasts the message to all the other nodes on the network. The topology typically consists of a system of terminals or personal computers, each connected to a central server. Data is transmitted from one computer to the next by packets. A packet containing the address of the sender and the receiver is first sent to the central hub, which then sends the packet to the designated computer. The following diagram is an illustration of a star topology. And my dear students and the rest of the learners, you can see that in this topology, we have a printer, we have a computer or several computers, and we also have a hub at the middle. So each of these devices, the hub, the printers, the computers, all of them can be called or referred to as nodes. So you can have a client node, and you can also have a server node. And in this case, the printer here can serve as a server node, while the computers, that is the laptops, can simply serve as clients. But also the hub can serve as a server node. The following are therefore the main advantages of star topology. Number one is adding new devices to the network is easy. So the network is easy to expand. Number two is if a computer stops working, the network is not affected. Number three, if one piece of cable is damaged, only one computer will be affected. Number four, it is easy to configure. Number five, it allows centralization of key networking devices, such as a server. Number six, it gives the network administrator a focal point for the network management. Number seven, communication process is increased greatly since no error control or routing burdens are involved. Number eight is since a single server handles the connection requests, it is possible to introduce a priority system for communication. However, this topology has its own disadvantages, some of which include, number one, it requires more cabling to install, hence making it expensive. Number two, if the central computer or server malfunctions, like if the hub malfunctions, the entire network will fail. Number three, only one computer on the network can send data at any particular time. Number four, installing this type of network topology is time-consuming because each node forms a segment of its own. Number five, if network communications activity is high, computer is forced to spend most of its time switching the messages rather than performing data processing. Number six, the number of devices that can be connected to the hub is limited based on the number of provisions that the hub contains. The other type of topology is what we call the line or bus topology. In this arrangement, all the devices are connected to a central cable that we call a bus or backbone. Transmission and reception of a message is done by all the nodes. However, only one node can carry out a transmission at any one time. Data is sent down the line in any direction in packets. Each packet has its own address or has the address of the sender and the address of the intended receiver. Each computer on the line examines each packet in order to determine for whom the packet is intended. If the packet is intended for this computer, it is retained for processing by that computer. Otherwise, if it is not intended for that computer, it is sent on its way to the next computer. In this type of topology, a terminator is required. A terminator is attached to each end of the cable in order to avoid the signals from bouncing back and forth on the cable, causing what we call a signal distortion. The network addresses of computers on a network is called medium access control address, or what we just call MAC address. So what are the main advantages of bus topology? Number one, with bus topology, extending the network is very easy because new equipment can be connected to it by simply tapping into the main cable. Number two, it requires less hardware to set up. Number three, it is easy to configure. Number four, it is less expensive because it does not require a complete cable length per computer. Number five, if one node fails, the others are not affected. Number six, it allows stations to communicate independently of each other. And number seven, transmission on the linear media is bidirectional, such that more than one device can communicate simultaneously. However, regardless of these advantages, this topology also has the following disadvantages. Number one, the simultaneous communication in the bus results to signal corruption that we call contention. Number two, the number of stations or terminals connected to the backbone are limited depending on the characteristics of the cable. Number three, the failure of the backbone will bring the whole network to a standstill. Number four is difficult to troubleshoot because the fault could be anywhere on the cable. And therefore, the following diagram is an illustration of a simple bus topology. My dear students and the rest of the learners, the most important key point to remember, in as much as all the others are also okay, the key significant feature of the bus topology is the bus itself. That is, that big bus, that cable in which all other connections are be done, which is terminated on each of its ends with a terminator. The third type of topology is called the ring topology. In this topology, all the devices are connected to one another in the shape of a closed loop. Here, the cable is connected to all the computers in the network. The ends of the cables are then connected together to form a loop or a ring. Data in this topology is passed from one computer to the next by means of a token, that is an electronic signal, which is passed around the ring, giving each computer an opportunity to send data. A computer can only send the data when it is in possession of the token. Each station is responsible for regenerating and retransmitting signals around the network to its neighbor. A token is therefore used to exchange data from one station to another. A token can be viewed as an envelope or a bag where data is placed for transmission, and that data is then carried within that bag around the network. It uses repeaters which are connected by point-to-point links in a closed loop. The links in a ring topology are unidirectional, and the data transmission takes place in a circular ring. This topology has some of the following advantages. Number one, they use a short length cable. Number two, it is simple to install. Number three is if a computer stops working, the other computers can continue to communicate. Number four, communication is usually faster than with a line network. Number five, it is well suited for a network with a fixed number of nodes. And number six, the packet delivery time is fixed and guaranteed. This topology also has its own disadvantages or limitations. Some of these disadvantages include, number one, if the main cable is damaged, the entire network goes down. Number two, the entire network has to be shut down for any maintenance to be carried out. And number three, the network becomes very difficult to maintain if it gets very large. Number four, it requires a lot of reconfiguration when new nodes are added. Number five, token management must be robust because loss or corruption of the token can cause chaos. Number six is if any computer breaks down, the ring circuit is broken and the communication between any of the computers cannot take place. However, this is not the case for IBM token ring, where a device called multi-station access unit, that is MSAU, is used for station bypass in the event a station fails. The following diagram is an example of the ring topology. The outstanding feature in this network is the backbone, which is a cable that goes around connecting all the nodes within it or into it. This other diagram is an illustration of an improved ring topology. In this case, if, for example, the cable between a single PC and the backbone and the ring is disconnected, it's only that computer that will be disconnected, and that will not interfere with the entire network. The fourth type of topology is mesh topology. In this topology, devices are connected with many redundant interconnections between the nodes. Each node has a connection to every other node in the network. It is the most common type of topology that is used in wide area network, where there are many paths between different locations. Its main advantages are, number one, each device is directly linked to another with multiple routes. If one link fails, messages can go another way. So this topology is very reliable. Number two is this topology provides for fast communication speeds, and it is also easy to troubleshoot. Its main disadvantages, however, are, number one, it is costly to provide the redundant cables. It is difficult to install and maintain. High overhead costs are experienced since most lines are idle at any one given time. They are expensive also to expand since a new station must be directly linked to all other existing stations, and it is also complex to design. The following diagram is a clear illustration of what we call a mesh topology. The most outstanding feature in this topology are the very many interconnections between each and every device. So a lot of wires, a lot of cables are used in formation or creation of this type of topology. As you can see, from this diagram. The fifth type of topology is called tree or hierarchical topology. In this topology, all the nodes are connected in form of a tree with nodes as leaves and links as branches. The transmission medium is a branching cable with no closed loops. The branches in turn can have more sub-branches, and these branches are connected to each other by means of devices that we call hubs. Then groups of star configured networks are connected to a linear bus backbone. It links computers in a hierarchical fashion and requires information to flow through the branches. Data needs to flow through a certain node before reaching the destination node. Its main disadvantages or its main advantages are, number one, failure of one or more nodes does not affect the whole network. Number two, unlike a bus topology, failure of a single branch does not bring the whole network down. And number three is functional groupings can be formed. This topology, however, also has certain limitations or disadvantages, which include, number one, data flow can be slow through this network because it must flow through certain nodes before reaching the destination node. Number two, if the top node fails, the network fails because it controls all other nodes. Number three, installation is expensive and complex. Number four, communication path can sometimes become quite long. And this is a diagram that illustrates this type of topology. From the look of this topology, you can see that on the top, at the top, we have a computer, which in this case can serve as a server. Then this computer is connected to a printer, and this single printer can print or can serve all other nodes that request for printing service. From these computers, you can see it is connected to a bus. So this is like a formation of a bus network at this level. But then when you look at it, you can see that in the bus or within the bus, we have this section being connected to the bus, and we have also this other section. And in this section, we can see that this is a star topology. We can see we have a central hub here, and we have this node, and this node, and this node connected to it. The same to this other side. So simply in a tree or hierarchical topology, we can be able to have various types of topologies interconnected to each other. And therefore, this can also even be called a hybrid topology because it is allowing several topologies to be interconnected to it. Let's now look at what we call transmission media. A transmission medium is the pathway that is used for carrying data and information from one point to another. This medium dictates the type of signal that will be used to transmit message. The two main categories of data transmission media are bounded media, that is communicating using cables, and unbounded media, which is wireless communication. What is bounded media? Which we also call use of network cables. In this media, or in this type of transmission media, the data signals are transmitted from the source to the destination through a restricted pathway, such as through a cable. The most common types of network cables or bounded transmission media are two-wire open line cables, twisted pair cables, coaxial cables, and fiber optic cables. Let's now look at each of these cables briefly, starting with the two-wire open line cables. This is a two parallel copper wires separated by a plastic insulator and used in telecommunication network to transmit voice signal. The two-wire is the most basic form of electrical cable consisting of two insulated copper wires. Two-wire cabling is suitable for low-speed transmission. Although the plastic insulator is meant to reduce interline interference that we call crosstalk, their linear nature allows an electromagnetic field to build around them during heavy data transmission, which may cause interference to the signal. Crosstalk is a problem where signals cross from one pair of wires to the other. It is caused when electrical signals in one pair of wires produces a magnetic field, which in turn causes a signal to flow in one pair of wires. This problem sometimes occurs with the telephone system when someone else's conversation is heard on the line. The wires also capture environmental frequencies, hence causing noise in the transmission channel. Noise is the random unwanted signals that are picked up by a channel. And therefore, this diagram illustrates this type of a cable. Number two is twisted pair cables. This is a cable that is made up of two solid copper wire strands hooked around each other in a double helix manner so as to reduce the development of an electromagnetic field around the two wires as they transmit data. This reduces the crosstalk problem that we have come across in our previous cable, which is the two-wire open cables. These cables are mostly used to transmit both voice and data signals. The individual twisted pairs are then grouped together and covered with a plastic jacket. If one or if no additional shielding is added before the papers are wrapped up in a plastic covering, then they are referred to as unshielded twisted pair. Otherwise, we have what we call shielded twisted pair or STP. And therefore, we have two types of twisted pair cables, which are unshielded twisted pair cable and shielded twisted pair cable. The shielding may be a metallic foil or a copper braid. Shielding minimizes electromagnetic interference or radio frequency interference. Therefore, the two common types of twisted pair cables, just as I have said, are the UTP and STP. What is UTP? UTP do not have a shield that prevents electromagnetic interference, hence they are susceptible to noise and signal interference that we call electric noise from the environment. Noise may come from lightning sparks, radio signals, and even radiations from spark plugs in motor vehicles. This cable is therefore not suitable for environments that are electrically noisy. A major reason for UTP's popularity is because this form of cabling is used in many telephone systems, although usually with a lower specification cable than the cabling used for networking. UTP is widely available and the specifications have been standardized. And here is a diagram to illustrate that. The STP is similar to UTP, except that a braided shield is wrapped around the wires to shield or protect them from noise. They have a braided wrapped around the wires, and its lines allows for a higher bit rates and longer distances. From this diagram, you can see that we have a cover followed by a shield, and then we move deeper to the twisted pair. Twisted pair cables are categorized into 5 groups according to the type of data transmitted and maximum rate of transmission. They can support high data rates or bandwidth of up to 100 megabits per second. So what are the advantages of twisted pair cables? Number one, it's easier to set up a network media because connection is readily available. Number two, installation equipment is cheap and readily available. And number three, it's cheap because of mass production for the telephone use. However, this aspect is being eroded these days because of the wireless communication. Its main disadvantages are, number one, it suffers high attenuation or low immunity to noise. It is sensitive to electromagnetic interference and eavesdropping. It has low data transmission rates as compared to other cables. And number four, it lacks ruggedness. Its main application area was in public switched data networks and also in LAN where lines are very short. The other type of cables are the coaxial cables, sometimes called the TV cables. This is a cable that has a central copper core made of solid or stranded wires that are surrounded by a dielectric material or insulator, which is then surrounded by a hollow mesh conductor that is covered by a shield, thus making the cable more resistant to electromagnetic interference. The diameter of the center core or conductor determines the attenuation rate. The thinner the core, the higher the attenuation rate. They have specialized insulators and shielding separating two conductors, thus allowing reliable high-speed data transmission over relatively long distances. They support the two types of networks. These are the baseband network and the broadband networks. The braid or mesh conductor is made of copper or aluminum and serves as the ground for the carrier wire. Together with the insulation and any fuel shield, the braid shield protects the carrier wire from radio frequency interference and electromagnetic interference. Data is carried on the cable using direct current. Coaxial cables have bandwidths of up to 1 gigabits per second. Hence, they are installed in a network to form the network backbone, that is a link that connects two or more separate local area networks. The two types of coaxial cables are the VNet, that is thin coaxial cable, and the VICnet, that is the thick coaxial cable. VNet has one dielectric insulator, while VICnet has two dielectric insulators around the core and is thicker than VNet. Due to the presence of copper sheath as the second conductor, coaxial cable has additional strength and can therefore be drawn over a long distance than the twisted pair. Large transmission rates of over 1,000 megabits per second are also possible without significant signal loss. So this diagram illustrates the VICnet and the VNet, and both of them have copper core insulation, braided shielding, and outer covering. The advantages of coaxial cables are, number one, they are very stable even under high loads. Therefore, they have capability of carrying more signals. Number two, they have a large bandwidth compared to twisted pair. That is, they have high data transmission rate. Number three, They can carry voice, data, and video signal simultaneously. Number 4, they are more resistant to radio and electromagnetic interference than twisted pair cable. Number 5, they have low maintenance costs, and therefore they have reasonable costs over short distances. Number 6, they are simple to install and tap. However, its main disadvantages include lack of security due to illegal taps. They are relatively expensive to buy and install. It's bulky, therefore difficult to work with, that is difficult to install. They are hard to work with, and they have limited distance and topology. The fourth type of cable is called the fiber optic cable or light guide cable. This is a cable that is used for transmitting data from one point to another on the network using light signals. The electrical signals from the source are converted to light signals, which are then propagated over the fiber optic cable. In order to convert an electric signal to light, a light emitting diode is required at the transmitter. Then at the receiving end, a photosensitive device is used to convert the light signals back to electrical signals that can be processed by the computer. The fiber optic cable utilizes streams of pulses that carry information inside hair-like strands of glass or plastic that is called optical fiber. It is manufactured by drawing a large cylinder of glass until it is almost one piece of pure glass whose diameter is in a millionth of a meter. The combined drawn glass and the semiconductor light emitting diode technology brought about fiber optic communication. One cable consists of thousands of those optical fibers. The fiber optic cable is made up of the core, the cladding, the buffer, string members, and the jacket, as we are going to see in the diagram that is following. The core is the central part of the cable that is made of a hollow, transparent plastic or glass. The cladding is a single protective layer surrounding the core that has some light bending characteristics to make the light trying to travel from the core to the cladding to be redirected back to the core. The buffer surrounds the cladding and is used to strengthen the cable, while the jacket is the outer covering of the cable. An optical transmission system consists of the transmission medium, the light source, and the light detector. Light from a light emitting diode or a laser shines into one end of the cable and travels by bouncing off in a reflection along the cable. A large number of fiber are packaged in a cable, which is then laid underground or in a building in the same way that electrical cables are laid. The fiber optic cables are of two types, that is, the single mode fiber and the multi-mode fiber. So what is a single mode fiber? A single mode fiber has a very narrow center core, making the light in the cable to take only one path through it, thus having a very low attenuation rate. It is preferred for long distance transmission. It is very expensive and requires very careful handling during installation. Multi-mode fiber, on the other hand, has a thicker core than the single mode. It allows several light rays to be fed in the cable at an angle at the same time, thus making distortion of the signal to be possible. They have a high attenuation rate and are usually used for shorter distances. And this diagram illustrates a fiber optic cable. You can see that it contains the parts that I have already mentioned, which include the core, which is innermost part, followed by cladding, then coating, then strengthening fibers, and finally, we have the cable jacket. These diagrams also illustrate the single-mode fiber and the multi-mode fiber. You can see that the single-mode fiber is thinner than the multi-mode fiber, which is thick. The single-mode fiber contains thin core and cladding, while the multi-mode has thick core, cladding, and jacket. The difference between single-mode and multi-mode is the size of the core in terms of thickness. So single-mode has a thin core, while multi-mode has thick core. The light signal travels through the core through a process referred to as total internal reflection. The process that causes total internal reflection is called refraction. Refraction is the bending of light when it crosses the boundary of two mediums that have different density. When a light signal is inserted into the cable, it tries to cross from the core to the cladding. The light is bent back into the core, hence propagates along the length of the cable from the source to the destination. So some of the advantages of fiber optic cabling include, number one, it is immune to electromagnetic interference and eavesdropping. Number two, it's fast and supports high bandwidth, hence high carrying capacity. Number three is large distance can be covered because it has low attenuation. Number four, can be used in hazardous places, that is highly flammable places, because they do not generate electrical signal. Number five, it is smaller and lighter than the copper cable, hence ideal for space-limited situations. It can withstand temperatures of up to 1000 degrees Celsius. It has the ability to transmit digital signals, and it supports simultaneous voice, data, and video applications. So what are the disadvantages then of this type of cable? Some of these disadvantages are, one, connecting devices and the media are very expensive. Number two, installation is difficult because the cable must be carefully handled. Number three, it is relatively complex to configure and thus requires skilled installation and maintenance personnel. Number four, a broken cable is difficult and expensive to repair. Number five, it's prone to water seepage and freezing. And number six, it is brittle. The data communication through the use of cables, that is bounded media, is also referred to as terrestrial communication and is affected by electrical and atmospheric disturbances. Let's now look at the other category of media, which we call unbounded transmission media, which we also call the air media. Unbounded media is a media that is used to transmit data from one point to another without using any physical connections and mainly make use of radio waves for transmission. Wireless communication is the transmission of data and information through the atmosphere rather than through wire cables in much the same way as the transmission of radio and TV signals. Examples of wireless transmission media include microwaves, radio waves, infrared, and satellite transmission medium. Let's now look at microwave transmission. Microwaves are high-frequency radio waves which travel in straight lines from a transmitter through the air to the receiver. The transmitter and the receiver, which have parabolic discs, must see each other in order to receive the signal without any obstacles between. A transmitter is a device which is used for transmitting, that is sending data or information, while a receiver is that device which is specifically used for receiving the sent information. The system uses microwave frequencies and applies the principle of line of sight communication. This means that communication is carried out over a direct line of sight path. The system consists of parabolic discs, which are directional to minimize the radiation power necessary for the signal to reach the receiver. Microwave frequencies range from about 3 gigahertz to 40 gigahertz on the electromagnetic spectrum. They have short wavelength and are suitable for point-to-point transmission in networking. This means that a signal is directed through a focused beam from transmitter to the receiver, and the transmission can be shown as I have highlighted in this diagram. And you can see clearly what we call the line of sight. Microwaves can only travel in straight lines and are blocked by buildings, hills, and the curvature of the earth. To travel long distances, microwave signals must be relayed between transmitters that are within line of sight of each other. The total bandwidth of a microwave channel is subdivided into numerous subchannels that are used for different transmission. Because the waves cannot bend with the curvature of the earth, they are relayed by means of dishes or antennas on high buildings and mountain tops. The advantages of microwave transmission are: number one, they operate at high speed. Number two, they have huge transmission capacity. Number three, it is less prone to transmission errors, unlike twist and pair. And number four, they are capable of operating in digital or analog forms. Its main disadvantages, however, include: number one, additional number of repeaters are added after every few kilometers. Number two, signal is affected by atmospheric conductors like lightning. Number three is that electromagnetic waves could be dangerous to human health. And number four, the initial installation cost is normally very high. Let's now look at satellite transmission or communication. A satellite is a microwave relay station that receives a microwave signal from a transmitter, amplifies it, and retransmits it to a receiver. In this transmission, microwave radio signal is transmitted from antennae from the ground to a satellite on the orbit around the Earth. The microwave radio signal is beamed to the satellite on a specific frequency that we call uplink frequency, where it is received, amplified, and then rebroadcasted on a different frequency that we call downlink. The satellite transmits the signal to many Earth stations to form a point-to-multipoint transmissions. Very small aperture terminal that we call VSAT is a technology used in microwave small satellite dish used both in data, radio, and TV communication. This technology enables direct access to go through the state-owned or licensed satellite gateways. The microwave dishes with an antenna fixed on them in order to focus a narrow beam towards the satellite in space. A satellite transmission system has three main components. Number one is the transmitter Earth station that would set up an uplink to the satellite in order to transmit data. The uplink will have a unique frequency. Number two is a satellite itself that is somewhere in an orbit high above the sky or high above the Earth that receives, amplifies, and retransmits the signal to a receiving Earth station via a downlink frequency that is different from that of the uplink, so as to avoid interference with the uplink signal. Number 3 is a receiving Earth station that would receive the sent signal on the other side of the globe. And this information, my dear students and the rest of the learners, is as illustrated in this diagram, where we have a transmitter Earth station that will originate data or information. Then the transmitter will convert that information into a signal, which will be transmitted to a satellite that is fixed or that is normally found within the airspace up in the sky. This satellite will receive that signal as an uplink and then relay it down to another section of the Earth to a certain receiving Earth station that will receive that signal and convert it to a form that can be accessed using a certain device such as a computer. A communication satellite is usually launched into space about 36,000 kilometers or 22,000 miles above the Earth's surface in such a manner that its speed will be relatively equal to the rotation speed of the Earth. An observer on Earth will therefore see as if the satellite is stationary in the space or is stationary in space. These types of satellites are called geostationary satellites. They are convenient because the need to keep on moving the parabolic dish in a bed to track the line of sight is eliminated. A geostationary satellite offers a large constant line of sight to Earth stations. The area on Earth where the line of sight can be easily located is called the satellite's footprint. The satellite transmits a signal to many recipient Earth stations to form a point-to multipoint transmission. In multipoint transmission, the transmitted signal spreads out in all directions, forming a cell of access radius. With the use of VSAT, the satellite produces strong signals that can be received by a satellite dish antenna of only about 2 meters in diameter. The signals are then decoded using a decoder which is plugged directly to a TV or a computer. Satellite is often used for long-distance communication. The beam of microwave that is sent to a satellite is received and retransmitted to the predetermined destinations using an onboard circuit that is called a transponder. A single satellite has many transponders, each covering a particular band of frequencies. So, what are the main advantages of satellite communication? Number 1, the cost is not dependent on distance. Number 2, Earth stations can be installed on a customer property than layering extensive cables. Number 3, it has the second highest bandwidth after fiber optic cables. However, some of its disadvantages include, number 1, there is delay of signals because they have to travel out into space and back to the Earth, what we call propagation delay. This is the amount of time it takes for it to travel from its source to its destination. Number 2, heavy rain or bad weather will increase the loss of signals. Number 3, any station can receive the signals. And number 4, it is expensive to install ground stations to support satellite communications. Let's now look at radio transmission. Radio waves originate from a central point and spread outwards in all directions, what we call omnidirectional. As they travel outwards, their energy spreads outwards over the covered area. The waves are radiated into the atmosphere by a radio frequency antenna at a constant velocity. These waves are not visible to the human eye. Radio waves are used in radio and television broadcasts. Data can also be transmitted over radio waves communication channels. Radio waves can be of high frequency, very high frequency, or ultra high frequency. Let's look at high frequency. High frequency is a signal, or high frequency is that signal which is propagated by directing it to the ionosphere of the Earth, which reflects it back to the Earth's surface, and the receiver picks the signal. The biggest challenge of high frequency communication is the danger of signal interception by unauthorized parties. Very high frequency. Very high frequency are radio waves that are transmitted along the Earth's surface. Due to the curvature of the Earth, the signal will most likely alternate at the horizon. This means that the repeater stations have to be placed strategically to maintain a line of sight in order to receive, amplify, and propagate the signal from one area to another. This technology is popular for the handheld devices like walkie-talkie radios. The range of very high frequency is limited, but it is preferred to high frequency where no major obstructions are encountered on the landscape. This is because with very high frequency, it is possible to make the wave to follow a narrower and more direct path to the receiver. To overcome the obstructions on the Earth's surface, like mountains and buildings, repeater stations are built on raised areas. Ultra high frequency. These are radio waves, or these radio waves are like the very high frequency waves when it comes to the line of sight principle. This means that there should be no barrier between the sending and the receiving area. However, they require smaller areas. Areas for very high frequency are bigger than those of ultra high frequencies because ultra high frequency radio waves can be made to follow an even narrower and different path to the receiver than very high frequency radio waves. Therefore, ultra high frequency is popular for horizon limited broadcasts. The following diagram illustrates a typical radio wave link between two separate geographical locations. From this diagram, you can see that we have a transmitter that has a transmitting antenna which converts the data or information into a wave or a signal, which is then received by a receiving antenna by a receiver on the other end. One of the latest radio transmission technologies is called the Bluetooth technology. This is a worldwide and short-range radio technology that enables people to use handheld devices such as phones and personal digital assistants to access the internet. The main idea behind Bluetooth technology is one standard that will allow all personal communication devices, regardless of their differences or size, to be able to communicate with each other and through wireless technology. The main component in Bluetooth is a small, low-power, two-way radio transceiver, small enough to be inserted in small devices. A network of Bluetooth-enabled devices is called a wireless personal area network, that is WPAN or Piconet. This is because Bluetooth networks are best suited for personal or handheld devices. This has made radio transmission to become popular in mobile communication and internet connectivity. The following is a diagram of a Bluetooth device. This device can even be inserted or connected into a USB port. For a device that does not have the Bluetooth facility, and by inserting it, then that device can be able to receive a signal through Bluetooth. In radio transmission, the information being sent is always transformed into electrical signal through the appropriate converter. In telegraphy, this converter is the push button, while in radiophony, it's a microphone. In television engineering and image analysis, cathode ray tube is used. However, this technology has also been replaced by other types of technology, thus eradicating the CRT tubes. The transmission speeds is measured in bits per second, BPS. Transmission speeds can be expressed through baud. The number of signaling events per second is known as the baud rate. Alternatively, baud rate is the number of times per second the signal on the communication circuit changes. Cellular radio has been developed over the last few years to enable the use of mobile telephones. With a cellular radio system, the country is divided into a number of geographical areas that are called cells. These vary in size depending on the number of mobile users in the area. In cities, the cells are small, while in rural areas, they can be much larger. With each cell, the phones can each operate on a different frequency so that privacy and security is maintained. Broadcast radio is where signals are transmitted in all directions and can be received by anyone with a suitable receiver. Data transmission rates are generally low, and there are obvious problems of privacy and security, so it is not widely used. Let's now look at infrared transmission. Infrared waves are not visible to the human eye. Communication through this medium is achieved by having infrared transmitters and receivers, which we call transceivers. Transceivers of infrared signals must be within a line of sight in the same room. This is because infrared signals cannot penetrate obstacles like walls. However, the signal can be reflected off surfaces like walls and the ceiling until they reach their destination. An example of infrared devices is the infrared transceiver on most mobile phones. Once activated, two people in the same room can send messages to each other using infrared technology on their mobiles without going through the mobile service provider, hence avoid being charged. In computer networking environment, this technology can be used to connect the devices in the same room to each other without the need for cables. For example, a computer to a printer. The computer's infrared transceiver must maintain a line of sight with the one for the printer. So, what are the main advantages of wireless communication? Some of the advantages of wireless communication or wireless transmission, or what we are calling unbounded transmission medium, are: number one, they are flexible in operation as compared to bounded media. Number two, they can span large geographical areas easily. Number three, information can be received even in remote areas that do not have high-cost physical infrastructure like telephone lines. However, wireless communication also has certain disadvantages, such as: number one, it is relatively difficult to establish and configure. Number two, the initial cost is very high. Congratulations, my dear students and the rest of the learners, for acquiring knowledge on the topic Introduction to Computer Networking. For more videos in various computer or ICT topics, kindly visit Emily Swap ICT YouTube channel. In addition, for you to be able to acquire various life skills as well as access various motivational and inspirational videos, visit Emily Swap Motivation YouTube channel. You can also kindly click on subscribe button and hit the notification bell for both channels if you have not already done so as to be able to receive immediate updates once any new resource is added at any time. For any further correspondence, kindly write it to us through the email emilyswap@gmail.com. Thank you very much for listening to me and be blessed.